Well, hi, good morning, and thanks for joining me in my shop. Today's the last day of June, and more glorious weather here. Oh my gosh, you should all be jealous of those of us that live in this part of the world, because wow, the weather has been fantastic. But I'm in my shop, even though the sun is shining. And what I plan to do today, because I don't want to think too hard today, is I'm going to test the tubes in the radio, which often is something I do later in the game. But I think I'm going to do it right off the bat. Now there's lots of tubes in this thing. There's 8 tubes in it. Here's the tube layout chart. And the thing is, there's lots of duplicate tubes. For instance, there's 3 BA6s in here. And there's 2 25 EH5s. So the actual amount of tube testing is quite reduced. It's not 8 different tubes. So I'm going to start with the 6 BA6s. The other thing I've done is I've put little number tags on each tube so I can write the results down and kind of keep track of what I'm doing. And we're going to start. We're going to start with this one. 6 BA6. Out you come. First thing, is it really a 6 BA6? Yes, 6 BA6. Okay, put this here. Let's go take a look at the tube tester now. Okay, 6BA6. Switch it on. 6BA6. So I should have had this set up. Shame on me for not doing it. I'm going to set it up and we'll take a look in a sec. Okay, I've got it set up for a 6BA6, but let's just double check. 6.3 filament, signal level 4, bias 10L. 52763, 52763, 4100, 4100, 33 on the meter, C on the plate. We're ready to go. These buttons are all up. Good. There we go. 6BA6 number 1. Okay, let's take a look for shorts. So with most of the tubes, when I test them on this tester, the needle goes up just a little bit during the some of this. I don't think that's a problem at all. Back to tube test. Okay, we're ready on the GM test. The expectation is 960 on the meter. By the way, the 960 on this tube tester, when it says 960 here, it's the direct reading on the scale. The actual transconductance, you would multiply the reading by 3 to get to actual transconductance. So that's just the way this tube tester works, and that's to make things simpler, so nobody has to make a division to try to figure out where the spot is on the scale. So 960 is of course right near the 1000 point. Here we go. So this is on the edge of being rejectable. Oh, wait a minute. Look at this situation here. Okay, I have to be careful. My tube tester's the socket's wearing out on it. So now we're well above 1000. So that's okay. Okay, don't peel that off. Let's get another 6BA6 and stick it in there. The next, like that 6BA6 we just did, I believe, is the AM radio IF amplifier. And we've got 2 more 6BA6s. These are in the FM receiver. Make sure it's a 6BA6. Yep. So I'll give it just a moment. Okay, shorts. Exactly the same as the last tube. There's no problem there at all. Is it warmed up? So it's going to come up right in the same reading as the last tube. And I'm really going to have to replace the sockets, or it's really getting very questionable here in my tube tester. Assumably the highest reading is the correct one. She's a winner. Okay, that's good. After all, this radio is working. It would be surprising if any of these tubes are seriously bad. bad enough to require a replacement. I'm just struggling over here trying to get the tube out. Hey, it's holding on to it. Wow, that's really gripping it. And this is certainly looks like a 6BA6. 6BA6. Okay, trying to stick the sticker not where the tube identifier is. Okay, let's stick it in there and we'll see what happens. Very same result, no shorts. What did I say about a tube that doesn't work? How could that possibly be? It's got to be the socket. What is going on here? So I'm watching this pilot light. The pilot light will flicker as the heater goes on and off. I think the heater was off. I don't think the heater made contact. Yep, I gotta do something about that. So I gotta double check for shorts. Okay, what do you say this time? Coming up, it's just passing the 960 mark, coming up to exactly the same as the other tubes. So, despite the challenges with my tube tester here, I think these three are all good. So, the next one we're going to do, I think we'll do the 12BE6 here. So that's this tube here. This one's got a lot of dirt on one side, so and these other ones didn't seem to have that one side dirt. Maybe these have been replaced. So 12, I can see the BE on it, so it's a 12BE6. Very good. I think it's a fairly quick matter to set this up, so let's just go ahead and do it. 12BE6, 6.3, signal level 4, 8L, 51763, 51763, 3000, 3000. 41 on the meter calibration. C for the plate. 1520. So this should come up to way up here when we go to do it. Okay. Look, put the tube in, Jim. Can't get a good test without the tube being put in there. Okay, I can see it's heating up. Let's watch. No problem. GM is supposed to be 1570, so that's up past the halfway mark. So just about, well, it's well above. Okay, this is a pretty important tube, and it's in good shape. Great. Next tube. Next tube, we might as well follow along here. Kind of. The next tube, why don't we do this guy here? So this is the FM tube. Take it out, make sure it's, I think it's a 6DT6. No? This is a, what is that? This is a, yeah, 6DT8. 6DT8. Right, 6DT8. Okay, I'll just stick that there. 6DT8. Okay. If we can get through this one pretty quick too. 6DT8. There it is. Twin triode. 2 tests to do it. 6.3 signal level 4, 19L for low. PGK76. PGK76 3510 3510 F for the plate. So we're going to flip the K1, P1, G1. This is a cathode plate and grid. This is how this tube tester is designed. So you can do fairly quickly a double tube like this. We're all set. Are you okay? Why am I hesitant? PGK7635. I don't know. Here we go. Well, maybe I'm hesitant here because this is actually kind of over here. There we go. Good. It's heating up. Short test. And if there were a short in one of these tubes, I think we would know it from having operated the receiver. I think there would be, you know, either wouldn't work at all or something egregious would happen. So for this tube, we're looking for 1190, just about 1200, which would be right around here. What do we get? Ooh, FM2 a little low. Okay, so the other, just flip these switches. And we'll do the other half of the same tube now. Oh, it's low too. Both low. Let's double check everything here just to be sure. Because anytime I get a bad reading, I say, wait a minute, I'm not quick to throw these tubes out for work. Because often, I mean, it could even be the contacts in the tube socket there. 19L. PGK76, PGK76, yeah, I gotta have these rights. 3510, can't be a problem there. F, can't be a problem there. Put these back. 1190. 1190. Was I stupid about 1190? 1190, 1200 is right here. That's significantly low. Both sections of the tube, or both tubes in there testing about the same. I wonder if they share a cathode. I doubt it, because I'm throwing this switch. I doubt it. The reason I would say that is if they share the cathode, which I highly doubt, then, you know, a weak cathode would explain both sides being weak. Well, okay, so I think that's significant enough that I'm probably going to have to try to hunt down a replacement for this. And you know what? I looked quickly on one of my earlier radios there a couple weeks ago. I couldn't find one. I got lots of time today to dig around. So we're going to put this guy back in, knowing that he's probably not going to work out. Now we're going to do the 12AX7 tube. This is the preamp for the two output tubes. Yeah, it's a 12AX7. So let's just carry on here. Get this quick as we can. Quickly, which way to 12? Here we are, 12. 12AX7. I almost got it wrong here. 12. Oops. 12. 12. Here it comes. 12. 12A. Come on. 12AX7. Here we are. 12AY7. 12AX7. Single test, but we'll be throwing these switches again because it's actually two tubes in one. There we go. 6.3, lower signal level of 218L. It stays about the same. PGK77. PGK77. And 3516. 3516. 3516. 47. F. Okay, just a quick double checking here. PGK77. PGK77. 3516. 3516. Okay, it's the same guy checking his own work, so if I made a mistake before, I'm liable to just duplicate it here. F. We're ready. Let's put in the 12AX7 tube. Go. Okay, so warming up. Any shorts? No shorts. Actually, there are shorts. I'm wearing shorts here today, so that's where the shorts are. Okay, let the humor roll, Jim. Wow. Okay. We just did the short test, no shorts. 1,000. I'm gonna say I'm rushing here because I want to go outside. 1,000. Way over 1,000. And the other half, way over 1,000. So this is a beauty. This is a 12AX7. You want this in your radio. You want it badly. Now, next two tubes. That's actually the last two tubes. Is this a 25 EH5? Somewhere on here it says that, I guess. Well, this looks like it's been cleaned off. I don't see any markings on it, but I think we can trust it's the correct tube. That's because the radio works and the other one looks the same too. So 25, let's dial it up there first. 25 E, uh-oh, that's not on here. 25, wait a minute, I'm not doing the alphabet correctly here. There it is, yeah. Filament voltage is set to 27.5. That's the closest choice to 25. Signal levels are very high at 8. Bias is 25 low. 1576G. 1576G. I'm like a pilot putting in the failsafe numbers here. 4, 3, 0, 40. Bombs are falling. 40C. There we go. So we're expecting 1580, and we flip the grid switch, only this, to get 2 tests. 2 tests. G1 and G2. Okay, that's the first time I've seen a tube that's looking for that. Good, put those switches up. Ready on the 27. Let's fire it in there. Now, the output tubes are generally the tubes that wear out. Because they work hard, they run hot, they have hot cathodes, kind of dangerously hot for your hand. So it's quite likely, especially since we found one other tube apparently worn out. That suggests some high mileage in this thing. Here we go, shorts. No. And now, there's a GM test. And what are we expecting again? 1580. So, above the middle. Above the middle. Oh, look at that. We're above the middle. That's good. I thought these tubes might be bad. Great. Let me put this one in, and then I'm just going to grab the other one. It also appears to have been cleaned off. There's no markings on it. It's perfectly clean. Remember, one of the tubes was covered in dirt on one side, but this one isn't. So either it's been cleaned off or it's a replacement. That's possible too. Okay, in you go. Got any shorts in there, buddy? No. And here we go. Once again, past the halfway. Should we go over there? Sometimes the switch is a little weak. My tube tester's wearing out here. Wow. Yeah, I'm going to have to attend to that. I don't think there's any problem. There's no reason for me to think there's a problem in the first place, because the radio largely worked. But now we know something. We know this tube is weak. Everything else is good. One tube weak. So I'll spend part of my day looking for an alternate to this. This can be, there's a European version of this. I can't remember what it is now, but it's easy to find out, or I can find one of these. I'll try and find something. I gotta find something actually, because I'm pretty sure this is weak enough. This is not going to work properly on FM. If I go, hey, thanks for watching this part. I'll see if I can find one. Well, I've roared through my tube collection, and look at all the replacements I found as fantastic, except not the right tube. These are 6DT6s, which I have a lot, but I need a 6DT8 to go in here. I don't have any, at least I haven't found one yet. I don't think I'm going to. Apparently these are a little scarce, these tubes. So I have an old tube, or use the camera here, tube substitution book I like to take a look at. And in here, it gives a 6AQ8 as a replacement for a 6DT8 with an asterisk. Go down here, asterisk. Parallel filament circuits. So I'm going to try to digest this, because I'm pretty sure I've got 6AQ8s. And of course, this tube is right up here inside the tuner. There's no fiddling around with the socket. I'm not going to take this apart and try to rewire the socket. So it's got to be a direct replacement. I don't think the 6AQ8 is going to do it, but what else? What other options do I have at this point? I don't have any other options. I got to pursue this one. So as awkward as it is, I'm using the pinout chart in this book to try to compare the pin relationships between those two tubes, a 6AQ8 and a 6DT8, and it turns out they got the same basic pinout. So I'm going to look into this a little bit further yet. So I have hunted high and low, and I cannot find a replacement for this tube. So let's try something I've never tried with any seriousness, and that's to rejuvenate a tube. First, I'm going to test this guy again. And 6DT8. And then there's a few steps in that can be taken. Okay, let me concentrate here. 6DT8. 6.3. 4. 19L. PGK76, PGK suspiciously 76, 35103, 510, okay. 37, so this is already set up for that too. F, right. Okay. So basically a tube that is weak is almost always due to the cathode being weak, and that's due to undesirable chemistry that's occurred on the surface of the cathode. It can be from gases and things like that that are inside the tube, unwanted gases and the like. So our first shot at this is to simply plug the tube in. We're gonna do the test on it, and we're gonna note where the pointer is. Whoa. Okay, so that's just an arrow pointing at where the pointer is. So our first attempt, now there's a two-part tube here. Oh, it's even lower. So that's really low. And where is it supposed to be? Just to remind me. 12, should have been way up there. So that second test is way down. The first step is to simply let the tube run at its normal operating voltage for an hour or two and see what happens. So let's do that. It's 4 o'clock. Okay, let's see what's happened here after a bit of time. Well, it's better. I don't know how much better that really is. Okay, so that's our first attempt. Oh gosh, don't do this. That's slowly falling. Okay, so now the next attempt would be to increase the filament voltage for a period of time. So we're just going to take it up one step here. On this machine it's going up from 6.3 to 7.5. We're going to let it run like that for half an hour or so. Just do a GM test with the extra. So hey, that's all it takes. Just run the filament hot. Okay, we'll let that sit like that for, oh, I don't know, 15 minutes or so. Okay, kind of forgot about what was going on here, so let's see what's happened. It's still there. Let's cool her off. I'm going to turn her down a little lower here. Just give it a moment. Okay. Here we go. So I'm watching it now. See if it's going up or down. That looks pretty good. So where we want to get to with this is 1200. Well, we're pretty darn close. Okay, let's try the other half of this tube. And that hasn't come up much. So I believe this tube serves 2 purposes in the tuner. Yeah, that's come up nice. Oh, yeah, my tube tester's a little wonky. I think it serves 2 purposes. It's just possible that having a little weak on one side isn't gonna. Well, who knows? We'll have to put it back in the radio and see if it's a better deal. But in the meantime, part of my brain came back to life, and I may have some European versions of this tube. I forgot to even check there. Maybe I'll be lucky. It's an ECC 85, I think. Okay, so just a little more time has gone by here, and let's just take a look at it. Well, it's hanging in there. It's 11. It's dropping slowly. I don't have a lot of faith that this is some kind of long-term benefit here that I'm generating. So we could try an even higher setting for a short period. So one of the procedures here is to raise the current flow through the heater, and then watch the test result go up, and then as it starts to fall down, apparently that's the time to end it at the high voltage. So let's try that. We're going to take, if I keep my finger on the test switch here, we'll take this up to 10. Oh, what was that? Yeah, jumping all over the place. It's going up. Oh, my smokes. Hard to tell when it's going to come down. Coming down now. Holy smokes, wrong switch. Yeah, there we go. Yeah, I shouldn't chuckle. I'm going to blow this tube, but I wouldn't be surprised if that's actually happening here. Okay, did that cause any benefit that I can see? We're at the regular voltage again. Oh, it's even lower. So certainly didn't help at that point. The other half, that's just not coming back. Okay, maybe I've brutalized this thing enough. I can't find my European tubes, of which I only have a few anyway. So the next thing really I should do is play that in the radio and see what is happening. Okay, let's give that a try. Oh yeah, I'm gonna grab that super hot tube there. Okay, all tubes in. Switch is off. First setting is what? What is the first setting? Let's take this out of here. First setting was, I believe, FM. Let's turn it off. Let's apply the power. Good to go. There we go. Okay, we'll give it full power here. Still warming up. Antenna remains just a piece of wire. Okay, that's tuned. Let's tune.
There's going to be a lot of hurt if that does not stop.
As Fauci put it, in a country already leading the world in COVID infections and deaths, this could all now get very bad. Paul Hunter, CBC News, Washington.
Ottawa is extending the ban on most foreign travelers for at least another month until July 31st. It started in March to help stop the spread of COVID-19. The order prevents entry into Canada by anyone who is not a citizen, permanent resident, or American traveling for
Just
essential
listening very, very
reasons.
carefully to it.
No word yet on whether a separate order for non-essential travel by Americans will be extended past July 21st. China has passed a sweeping
Let's see if I get some strong music on here. There. Maybe I'll learn how to work that knob. That's great. Okay, it sounded fine. I don't know if I really improved this tube at all. I can't remember for sure how this sounded on FM before. It's just too many radios in my head. So, no harm done in any case. And for now, hey, that was pretty good. Great. Guess what time it is now? Hey, it's time to get the barbecue going and get out there and have some dinner. Thanks for watching, and we'll carry on tomorrow with this radio.